So when we talk about extrema or extrema, that means one of two things, either a maximum or a minimum, right? High points or low points, peaks or valleys, right? So there's different types of maximum and minimums. There's absolute. Absolute means the absolute highest point. Absolute maximum is the absolute highest point over an interval. Absolute minimum is the opposite, the lowest, absolute lowest point. Nothing lower than, no lower y value, no smaller y value than that, right? Biggest y value, smallest y value. Relative, sometimes it's called local, but most of the time it's called relative. Relative maximum minimums means just in that general vicinity. In that general vicinity, is that a high point or a low point? So it doesn't have to be the overall highest or lowest, it just has to be within that neighborhood. Is it a high point or low point? So I have a graph here, and I kind of labeled some, right? The A would be so from A to E. So the interval goes from A to E. A is the absolute minimum because that's the lowest y value, right? If I were to make a dot there, that would be the lowest y value from A to E. Absolute is right here. That's the biggest y value overall, right? Those two are biggest overall. But then if we kind of focus in a little bit, in this neighborhood, B is the highest point. Is it the highest point overall? No. But it's a high point, right? So we call it a relative maximum, not because it's not the highest, but it's a high point for that area. Same thing here. In this area, C is a low point. It's a valley, right? Is it the lowest? No, so we don't call it absolute, okay? D is both. D is both because is it the absolute top highest y value? Yes. Yeah. Is it the biggest in that area too? Yes, right? Okay. So that's what relative, that's the difference between relative and absolute. Absolute means no bigger y value. Absolute maximum means no bigger y value than that over the whole interval. Absolute minimum means the absolute lowest, smallest y value over that whole interval. Relative means it's a high point. Is it a high point? Yeah. Is it the highest? No. Is it the biggest y value? No. Okay? So this is what the picture looks like. Problem is, this is the only picture we're going to see today. Okay? So we have to figure out these without the picture. Yeah, it's really easy if you got a picture in front of you, right? So we got to figure out a way to figure out where these guys are without that picture. There's a couple things I'm gonna give you. There's a couple of tools that we can use to make it easier. Okay, so before we go on though, in terms of derivatives, so what is a derivative? When I say a derivative, what is a derivative? What are the words that go with derivative, the phrase that goes with derivative? Slope of the tangent line, right? Those are the three buzzwords, slope, tangent, line. Okay, so in terms of slopes of tangent lines, what do you notice about the maximum and minimums? So let's start with, don't worry about the absolute so much, I'm more talking about the relative. What do you notice about a slope at that point there? What would a slope of the tangent line look like there? Would it be positive? Would it be negative? Would it be zero? Would it be undefined?
Of a vertical tangent? Or?
So what would it be? So what would it be? So let's start with an easier one. This blue line here, that blue dot. What would the slope be of the tangent line for this blue dot? Would it be positive? Would it be negative? Or would it be zero? Why positive? You're right, it would be positive. Why?
Because it's going up.
Yeah, because it's increasing, right? It's increasing. The tangent line will look like that. That's a positive slope, right? Yeah. Okay, so let's go to the other blue dot, the one here. What would it be there? Would it be increasing? Would it be positive slope, negative slope, zero? Undefined. It would be zero, right? So what about down here? It would be 0 again, right? So can we come up with a generality? When is slope of the tangent line 0?
When it's
At a relative
Relative
or absolute?
maximum or minimum, right? Relative maximum or minimum. What causes the slope to be 0 at those dots? So at these blue dots here. What causes the slope to be 0?
As soon as they get to their spot, they go the opposite direction.
They change direction, right? Don't they change direction at each of those blue dots? At the relative maximum, it's increasing. And then what happens right after the blue dot? Decrease, right? Changes direction, good. Relative minimum, it does the opposite, right? Decrease, change to increase. Relative maximum, increase, change to decrease. So that is where we find those blue dots. So if we can tell where slope changes signs, we'll find a maximum or minimum. Okay, we'll find a relative maximum or minimum. Okay, so that's the first thing we're going to do. First thing we're going to do is find the relative maximum and minimums. And then once we get comfortable with that, then we'll look at absolute. I'm not worried about absolute right now. So how do we do that? Here we go. Here's some important info down at the bottom. If you didn't know it was important info, it says right at the top. Okay, so important info to know. A function may have both a maximum and a minimum over an interval. It could either have only a maximum, it could either have only a minimum, or neither. Okay? So just because you have a maximum doesn't mean you have to have a minimum, or vice versa. It doesn't even have to have either. Okay, so just be sure of that. Okay, it's yellow on here, but not on your paper, I know. Critical values. So critical values are values where the derivative is 0. So let's go back to our picture. Let's go back to our picture here. The blue dots, we said, are where the derivative is 0, right? Those blue dots are called critical values. Okay, those are called, so when I say critical values, I'm talking about blue dots, blue dots, blue dots. And actually, if there's a blue dot, even though it's not a maximum or a minimum, that guy right there is actually a critical value too because the slope is 0. It doesn't change direction, right? It goes from decreasing and stays decreasing, but critical value, the definition of critical value means the slope is 0. Okay, yeah. Yeah, right here too, yeah. Good job, yeah. Right there. Okay. All right. Okay, so getting back to it, AKA horizontal tangent lines. Or f prime does not exist, AKA vertical tangent lines. So if there is no derivative, asymptote, things like that, okay? It's a critical value. So the critical points or numbers are x values. So the critical values, we always are x values. So x is whatever. While maximum and minimums are the y values. So it depends on what they're asking. If they're asking for just the critical values or the critical points or critical numbers, just give the x's. X equals this, x equals that. But if they want to know what is the maximum or minimum, then that's the y value. Okay, that's the y value. All right. So in other words, if the point 2, 70 is a relative minimum, we would say the minimum of the function is 70, because that's the y value, and it occurs at x equals 2. Okay, so that's how we would note it. Because sometimes when you say, what's the minimum value? I have students that say 270. No, we don't want the 2 and the 70. I just want the y value. Okay, I just want the y value. Okay? Okay, so where are those guys? How do we know, without looking at a picture, how do we know that's a maximum or minimum? Well, we said if it changes direction, right? If the function changes direction, if it goes from a positive slope, increasing means positive slope, right? Decreasing means negative slope. If it changes, there has to be a 0 somewhere in there, right? There has to be a 0. So if the derivative is positive, if your derivative is positive, then f is increasing. The function is increasing.
Okay.
Okay? So that means
Oh, it's continuous.
between a and b, the function is increasing. So the derivative is positive. Between a and b, the derivative is positive.
Yes.
Okay? The derivative is also positive from c to d. Okay? All right, so let's go to the next one. If f prime is less than 0, negative in other words, right? Less than 0 means negative. If the derivative is negative, that means the original function is decreasing, right? If f prime is 0, that means it's not increasing or decreasing. It means it's constant, horizontal tangent line. In other words, horizontal tangent line. Okay. So that's how we're going to do it. So what we're going to use is what we call the first derivative test. The first derivative test tells us where the function is either increasing, decreasing, or constant. Okay? All right, that's how we're going to do it without a picture. Okay? All right, so let's look at example number 1. Example number 1. Okay, so for f of x, find the critical numbers. Those are x values, right? Critical numbers are x values. And then where it's increasing, decreasing, and then find all relative extrema. That means maximum and minimums. So we got to find all relative, max, and mins. Okay? So to do that, we're going to use the first derivative test. So we're going to use the first derivative test. The first derivative test says where, it'll tell us where the function is increasing, where the function is decreasing, and where it's switching from increasing to decreasing or decreasing to increasing. Well, in order to do the first derivative test, shocker, we need the first derivative. Okay? So let's find the first derivative. So there's no y's in here, so we don't have to do dy dx. It's just regular old derivatives like we did last chapter. 3x squared minus 12x, and that's it. Okay, that's the first derivative. Now to do the first derivative test, I have to figure out where the derivative is positive, where is it negative, and where is it 0. Well, the first thing I'm going to do is find out where it's equal to 0. Where is the derivative 0? That's the first thing I'm going to do. Okay? So to do that, I need to set it equal to 0. So the first derivative equal to 0. And then I have to solve. Oops, it'll be 12x. It's a binomial, so we can use GCF. They both can be divided by 3x. So that leaves us x minus 4.
Oh, I was
So 3x equals 0. X minus 4 equals 0. Divide by 3, we get x equals 0. That's one of my critical values. X equals 4, that's another one of my critical values. Okay? So those are critical values. These two are where f prime of x equals 0. That's where that's, so that is going to be either one of those blue dots that we saw. There's definitely going to be blue dots at 0 and 4. We got to figure out, are they increasing or we have to figure out, are they relative maximums or relative minimums? Okay? So to do that, next thing we do is I'm going to make a little number line here.
Oh, no.
Okay? What am I going to put on the number line? The two numbers I just found. 0, positive 4. Those are critical values. So what I'm checking now is to see before 0. So when x is negative, was the function increasing or decreasing? Between 0 and 4, is the function increasing or decreasing? After 4, is the function increasing or decreasing, right? In other words, is the slope positive or negative? Okay? So what I'm going to do is I'm going to pick a value in between. So the first one is 0. So left of 0 is negative numbers, right? You can pick any negative number you want. I would suggest picking an easy negative, but you can pick any negative. I can pick -1, I can pick -2.5, I can pick -10.6, I can pick -1,000,000. It doesn't matter as long as it's somewhere over here. Okay? I would choose the easiest one. -1, -2, perfect. That works just as well as -12.26, right? You don't want to choose random numbers. You want to choose numbers that are easy, especially because we can't use a calculator. So what I'm going to do is the first derivative test. If it's the first derivative test, that means I'm going to plug in whatever number I chose into the first derivative. Okay? So I chose -1 because it's left of 0 and it's easy to work with. Could I have chosen -2, -3, -4? Yeah, sure, but I want to keep this as simple as possible. So now what I'm going to do is I'm going to plug in -1 and see what kind of number I get, positive or negative. So -3 plus 12 equals +9. So that means the slope at -1, when x was -1, the slope was 9. So was it increasing or decreasing?
It's
Did I do something wrong? Oh, squared. I forgot the squared part. I forgot the squared, yeah. So that would be +3. 15, yeah. Okay, so let me ask that question again. Is it increasing or decreasing at -1? Increasing because it's positive. The slope is positive. Because the slope is positive, right, we would say increasing. So what I'm going to do over here is left of 0, I'm going to put a plus. It doesn't matter what number you chose. You could have chosen any negative, you would have gotten a positive answer. You can try it if you don't believe me. Plug in any negative, you would have got the same answer. Or not the same answer, but the same sign. You would have got a positive number. Now I got to choose a number in between 0 and 4. 1, 2, 3, 3.5, 2.6, whatever number you want. Again, keep it simple so that you don't have to struggle with it, right? This is the part, we don't want to struggle with this part. Okay? We don't want to struggle at all, but especially with picking our own numbers. Okay? So I use 1. Can you use 2 or 3? Yes. So let's see. 1 squared minus 12. It's the first derivative test, so we want to make sure we plug it into the first derivative. Okay? So I get 3 minus 12, which is -9. So is our slope, is it increasing or decreasing between 0 and 4?
Go down.
Decreasing, good. Negative between 0 and 4. Okay. Now, the only thing left to choose is bigger than 4. Pick a number that's bigger than 4. I'll choose 5. Sometimes 10 is easy because it's a round number, so 10 might be easy. I just chose 5 because it's close to 4. So we got 3 minus 12, so we got 5. 5 squared is 25 times 3 is 75. 12 times 5 is 60. Positive 15. So it's increasing again, right? So it's increasing again, okay? So f, the original function, before 0 was increasing. And then at 0, it switched and went decreasing. And then at 4, it switched back again to increasing. That's what the picture should look like. If I were looking at the picture, that's what it would look like. I would look for something that started at increasing, then switched at 0, and then switched again at 4. Okay? So let's answer the question now. We haven't even answered the question. Critical values, critical numbers. So our critical numbers were here. Or critical numbers or critical values, whatever you want to call them, they're all the same. We're at 0 and 4. X equals 0, x equals 4. Okay? Increasing and decreasing. All right, so let's write increasing. Where was the function increasing? From where to where was it increasing?
-1 to 0.
Not -1. Before 0. So how do we write before 0? Negative infinity. And when did it switch to decreasing? 0. Is that the only place it was increasing? No, right? Or 4 to positive infinity.
We have to do this.
Decreasing.
8.
Where was it decreasing from?
0 to 4.
0 to 4. Okay. That's that part. And then the last thing is label all relative extrema. So relative extrema mean maximum or minimums. Okay. So did we have a relative maximum? When do I know if I have a relative maximum or a relative minimum? Taylor?
If we have critical values.
At the critical values, right? So 0 and 4. Is 0 a maximum, relative maximum, or relative minimum? Look at the arrows, right? Going up, coming down. That creates a maximum. So we have a relative maximum. So let's write this down. Relative maximum at x equals 0. Now, I know this question didn't ask, but they're going to ask you, and I want to write it down in our notes. What is our justification? So justification means, why are you saying 0? Well, we just said it, right? Because the derivative, f's derivative switches from increasing, positive, to negative, decreasing. When the slope changes from positive to negative, that's increasing to decreasing. When that change happens, that creates a relative maximum. Okay. Now, did we have any relative minimums? Yeah, we did, right? We had relative minimum at x equals what? At x equals 4. Justification, because f's derivative, f prime, switches signs. What does it switch from? It switches from negative to positive. Okay? That's how I know that I have a relative maximum at 0 and a relative minimum at x equals 4. Okay? Because, yeah, they're going to want justification on tests and quizzes. They always want justification. So the justification part is just as important as the actual answer. Great, you know it's at 0, why? Great, you know it's at 4, why? Why is that? So that's a big thing we're going to focus on. Why is it? Because when these questions are worth 3 points, they're going to give you a point for the answer, but then they're also going to give you a point for the justification. And then the third point will come from the work. Okay? So even if you have the correct answer, you're not going to get full credit because you have to have justification. All right? Okay, example number 2. Let's go to example number 2 now. Is this not, there we go. Okay, so this one, they want us to find the x-coordinates of all relative minima. Minima is just the plural of minimum. That's all it is. So if there's more than one, it's called minima. If there's just one, it's called minimum. Okay?
Maximum.
All right. So they only want these guys here. They only want these guys here. Well, how did we get this number on this problem, on number 1? How did we get 4? And how do we know 4 was a minimum on this problem?
This was from being negative to positive?
We had to do the first derivative test, right? We had to check the first derivative, right? So even though it's asking us for not as much, we still have to do the same amount of work, yeah.
Yeah.
Right? So first derivative test is always for increasing or decreasing, right? So now we have, so first derivative test means find the first derivative. So we get negative 3x squared plus 6x plus 45. Find out where that's 0. Find the critical values. So we got to find the critical values or critical numbers or whatever you want to call it. That is where the first derivative equals 0. Okay, it's a trinomial. GCF, I can divide them all by, let's see, negative 3.
Not the quadratic.
2x squared minus 3x
2x squared.
minus, oops, yeah, it should be 1, sorry. 15.
2x squared. Yeah.
Okay.
Also 2x.
All right, however you did it, however you were taught in Math 2 and Math 3, most teachers teach the 2, yeah, 2x, yep. Okay. However you were taught back in the day to do this, I've never had a problem in calculus where I had to use the quadratic formula. They're all factorable because it's not, the quadratic formula is not a standard that's covered in calculus. Solving quadratics is one that's covered in Math 2, and then solving polynomials is one that's covered in Math 3. But again, we don't find those things, we use them. So however you want to figure it out, like some of the teachers teach the little x thing, that helps great, right? A times c is negative 15, negative 2. Trying to find the two numbers that multiply to be negative 15 and add to be negative 2. Negative 5, positive 3. Right? Whatever method you were showed back then, that's the method I teach. Okay, so.
Does he know the method?
Right. Okay. Now we got to solve. Figure out our answers. Where are the critical values? Well, x minus 5 equals 0. X plus 3 equals 0. Add 5. Minus 3. Those are our critical values. Positive 5, negative 3. Do we leave the negative 3 up there? That's just the GCF. That's not going to affect the answer.
If any of them are 0, it's all 0.
Yeah, if there was an x with a -3, then we would have got 0 as one answer. But if there was no x, then it doesn't affect the solving. All right, so now let's make our number line. Because we got to figure out where this is increasing, where this is decreasing. So we have a -3 and a +5.
Oh, wait, no. That's not.
So which numbers are we going to pick? Or what kind of numbers are we going to pick? You don't have to tell me exactly because we have options, but what numbers do I pick? I could pick what? I could pick -4 for numbers that are left of -5, less than -5. I could pick -4. That would work. So let's do that. So where am I plugging in -4? To the original or to the derivative? Because it's the first derivative test, yes. Okay. So plug in -4 to the derivative. So here's the thing. You can plug it into the -3x² plus 6x plus 45, or you could plug it into the factored version. I'd rather plug it into the factored version because it's a lot easier math. They're the same thing. One's just factored, one's not. So I would prefer, especially because I don't have a calculator, to plug it into this guy, -5 plus 3. So I'm going to plug -4 in and -4 in. So I get -3 times -9 times -1. I get -27. So what does that tell me? What does -27 tell me? How do I use that number, -27? Because that's what this chapter is all about. Okay, you got -27, what does that mean? That's a question I'm going to ask you guys a lot this chapter. It means it's decreasing, right? It means it's decreasing. Anything before negative, left of -3, the function is decreasing. Okay? 27, the number 27 is meaningless. What is the important part? The negative. The negative. Okay? I could care less what number it is. I just want to know if it's positive or negative.
That's so mean
Where
to
did the
me.
square root go for the -3, and then inside the parentheses x squared? Isn't it? Where did it go? I've lost.
Right here.
Oh yeah, where's the square root?
What square root?
It's an x times an x, right?
I just did. Yeah, I just did. I just divide them all by -3.
Soraya, are you?
That's not the quadratic formula.
Yeah, I didn't have to use a quadratic formula. You can if you want. It works, but I would suggest staying away from that because it just takes time and, you know. But yeah, it works, 100%. If you did the quadratic formula to get 5 and -3, I'd give you 100% if you got it right. Okay? Okay, so now we got that guy. What next? What's the next value we should choose?
I don't know. Anything between -3 and 5?
Okay, anything between -3 and 5. What's probably the best number to plug in?
I just plugged in 1.
0. Always plug in 0.
Well, I plugged in 1.
I plugged in 1 too.
I plugged in base 1 because I'm still.
0 cancels out like everything. So I would use 0 if you want to use 1, if you want to use 2, if you want to use -1, -2, go for it. It's not wrong. You'll get the same sign. You'll get the same sign. That's all we care about are signs.
That's why I plugged in 1.
So I get 0 plus 45 because I plugged it into the original derivative.
That's why I plugged in 1.
45 is positive, so that means it's increasing between -3 and 5. Don't assume that it's going to be decreasing after 5, because sometimes it'll stay positive. Okay, so don't assume. Make sure you always check. Number bigger than 5, 6, 10, whatever you want. I usually choose round numbers, so 6 works, but I'm just going to plug in 10.
Ew. You don't like 10? No. I'm not doing
-3,
times
5 times 13. It's going to be a negative number.
I'm doing
Yeah, it's negative, what is it? Negative,
6.
I have no clue. 15 times 13, I don't really care what it is. I just want to know I just need to know it's negative.
What?
Huh?
Okay.
Leave me alone.
All right, so now we can identify what's a maximum and what's a minimum. So we said before left of negative 3, the function is decreasing. Then at negative 3 all the way to negative 5, the function then increases. And then after 5 to infinity, it's decreasing. So when we do that, we create a relative max at x equals what?
You need max though.
Max 5.
Oh, sorry, minimum.
You don't need them.
Yeah, we don't need max.
You don't need no max.
Sorry, minimum. Where do we create, where is a minimum created? Relative minimum.
-3.
-3, right? -3. Justification, because how did we know the arrow was going down and the arrow's going up before and after -3? What told us that the arrow's going down and then the arrow's going up? What told us that? What switched? You're right, there was a switch. What switch?
The switch between the slopes, positive and negative.
Because the derivative, right? The derivative switched between, what did it start at? Negative. And then it switched to positive. I should say switched from negative to positive. Okay? So be careful when you're writing your justifications. I had this on tests before. They say relative minimum at x equals -3 because it switched from negative to positive. I couldn't give full credit because what is it? It doesn't tell me what it is. You have to tell me the slope of f of x, f prime of x. One of those things you have to tell me, okay? So I need to know so for the justification, I need to know what switched and what did it switch from, okay? So f prime of x, and then from negative to positive, okay? Just make sure you have those things on there so you can get full credit. All right. What do we got here? Oh, we got time. No, we don't have time. Let's look at the next one. Uh-huh.
The previous problem, what does it, so don't we find the x coordinates or?
We only need to find the minimum.
So the x coordinates, right?
X equals -3.
X equals -3.
Alright.
Yeah, that's the x coordinates.
Oh, okay.
That's an X coordinate.
Go back to your thing.
We'll find the y later.
With a chopstick.
It's a hairpin, actually.
Okay. So this one
It's actually.
is the same type of problem, if I can get it to not be blurry. It's the same type of problem. The only difference is it's just a different function. So I want you to start this. Will you finish it today? No, probably not, because we only have about 6 or 7 minutes. But find as many of those things as you can, right? Find as many of those things as you can.
Oh no, I don't want to find derivative.
Okay?
Gotta find everything.
We gotta find a derivative, man. We gotta do quotient rules.
Okay, so once I find a derivative, I found the first derivative was x squared minus 4 over x squared plus 4 quantity squared. What do I do next? I got to find the critical numbers. I got to find increasing, decreasing, and then relative maximum or minimums. So what do I do next?
Find what X is.
Say it again, find what x is.
Yeah.
How do I do that? You're right, but how do I do that?
0.
Set it equal to 0, right? So look at this guy. What's going to make it 0?
Oh no, so wait, no, look at this. It might be giving us like 0 to 0. Anything that makes the top 0.
There you go. Anything that makes the top 0. So set the top equal to 0. What would the bottom do? If the bottom was 0, what would that do? Undefined, right? Is that something we need to worry about for critical values?
Yeah, because, oh wait, no, because the critical value is also when it doesn't exist.
Or, right? You see or. So I have to take both into account. So set the top equal to 0. Set the bottom equal to 0. Those will be our critical values.
Oh, we need to find both. Oh no.
So critical values, I'll call them CV. X squared minus 4 equals 0. And then x squared plus 4 squared equals 0.
Oh, it's plus or minus 2. It's a square. Okay.
So this one is difference of squares, or you can just add 4 to both sides. And then take the square root. The square root is either going to be positive 2 or negative 2. Why is the other one not even worth solving?
Oh, it's just that. It's essentially, wait, no, because anything we're going to get is just going to be positive.
There's no number I could plug in there that would make 0. Negative, positive, it doesn't matter. Any number I plug in to this guy here, you're never going to get 0.
Pi.
Any number, positive, negative, because the first thing I do is square it and then add 4. So anything squared is going to be positive, plus 4 isn't going to be 0. I want 0 in the parentheses, and there's no way for me to make 0 in the parentheses. So is there a number? Yeah, but it's imaginary, and we don't deal with imaginary in this class. Okay? So the only critical values are going to be positive 2 and negative 2. Okay? All right, we'll pick up from there tomorrow. We'll pick up from here tomorrow.